Lesson 2, Sine and Cosine of Complementary Angles. Using triangle PQR, we are going to complete the following table. So using angle P as our first angle, as you can see it's labeled under theta here, we're going to find the functions of that angle in terms of sine, cosine, and tangent. So by this point in time you should have remembered that sine is the value of the opposite over the hypotenuse. So the sine of angle P is 4 over 5. And if you would like, you can label the hypotenuse. Cosine of angle P is the adjacent over hypotenuse, so that's 3/5. And tangent is opposite over adjacent, so the tangent of angle P is opposite 4 over adjacent 3. Now we're going to switch the angle to angle Q for theta. So sine of Q is opposite 3 over the hypotenuse of 5. Cosine of Q is adjacent 4 over the hypotenuse of 5. And tangent of Q is opposite 3 over the adjacent 4. So the patterns that you should notice in this chart is that the sine of angle P is equal to the cofunction cosine of angle Q. And angles Q and P are complementary. That means their sum is equal to 90 degrees. And the other one, cosine of angle P, is equal to the sine of angle Q. And the other thing that you can notice also is if you look at the tangent values for each of the angles, they're equal to the reciprocals. Okay, so reciprocal means to flip. Okay, so we can remember that with refliprocals. So the tangent value of the complementary angles are equal to the refliprocals or reciprocals. So we're going to find the values of triangle ABC, and we are not going to simplify the ratios because we are going to get radicals in the denominator, and typically we have to rationalize the denominator, which we will do in the long run. But for right now we're just setting up the relationship of the sides to the function of the angles. Okay, so the sine of angle A, opposite over hypotenuse, so 2 over radical 13. Cosine of angle A, adjacent over hypotenuse, is 3 over radical 13. And tangent of A is opposite over adjacent. Sine of angle B, opposite over the hypotenuse. Cosine of angle B, adjacent over the hypotenuse. And tangent of angle B is opposite over the adjacent. Okay, so do the patterns found in the opening exercise still work? So as you can see here, we have sine of angle A is still equal to the cosine of its complement, angle B, and the same goes for the sine of angle B is equal to the cosine of angle A. And the last two values for tangent are reciprocals. So yes, indeed, they do still work. That's a resounding yes. Okay, so for example 2, we're going to consider right triangle ABC where angle C is the right angle, so that means across from it is the hypotenuse. and we want to find the sum of angle A plus angle B. We know that to equal 90 degrees because of that property that we learned early on in this course. Find the ratios for sine of A and cosine of B. So sine of angle A is opposite, which is BC, over the hypotenuse of AB. And the cosine of angle B is adjacent, so that's BC, over the hypotenuse of AB. So what we notice is that they are indeed the same ratio. So part C says find the ratios for cosine of A, so that adjacent over hypotenuse, so that's AC over AB, and the sine of B is opposite, which is AC also over the hypotenuse of AB. So those values will be the same. So here's the important discovery. The acute angles in a right triangle are always complementary. The sine of any acute angle is equal to the cosine of its complement. So using the two equations listed right here, how can we rewrite sine of A is equal to cosine of B in terms of one angle? We can either write sine of A is equal to cosine of 90 minus A, or cosine of B is equal to sine of 90 minus B. So let's find the value that makes each statement true. So since we know these angles are complementary, we can say that sine of 90 minus 32 is equal to the cosine of 32. The difference between 90 and 32 is 58. So sine of 58 degrees is equal to the cosine of 32 degrees. Okay, so for B, sine of 42 degrees, that is equal to cosine of 90 minus 42. So sine of 42 degrees is equal to the cosine of 48 degrees. So since the sum of the two angles have to be equal to 90 degrees, I'm just going to take theta and write it as a sum with the other angle, theta plus 20, and make an equation by setting it equal to 90. So 2 theta plus 20 is equal to 90. My two-step equation, subtract 20 from both sides, drop to 2 theta, and divide out the 2. In effect, I get 35. So cosine of 35, I'm going to substitute the values in for theta now, is equal to sine of 35 plus 20, which is equal to 55. Again, take the two angle measures, set them equal to 90, solve for x. Go back and substitute in. So cosine of 60 is equal to sine 60 minus 30 is 30. In right triangle ABC, the right angle at C, sine of A is equal to 2x plus 0.1, and cosine of B is equal to 4x minus 0.7. Determine and state the value of x. Well, since we have cofunctions here, the sine of A and cosine of B, we know that they have equal values. So we can set 2x plus 0.1 equal to 4x minus 0.7. We can go ahead and solve for x. I'm going to subtract 2x from 4x, and I'm going to add 0.7 to the 0.1. Cancels out here, cancels out here, so we get 0.8 is equal to 2x. Divide by 2 on both sides to get x by itself, and in effect we get x is equal to 0.4. So going back to triangle ABC with a right angle at C, we know that angles A plus angle B is equal to 90 degrees. So those are acute angles. And we also witnessed that the sine of angle A is equal to the cosine of its complement, angle B. So knowing that, we're able to solve problems and write this in terms of one angle. So the sine of A is equal to the cosine of 90 minus angle A. So that's all there is to this lesson. You can conclude in doing the homework.